Good day. I'm going to start a series of small lessons on the t-statistic with a bit of an intro to statistics. I'm assuming that some of the people in this class are not familiar with statistics, and I want to just sort of ease us in. So we use statistics for a lot of different things. One of the biggest, most common things we do with statistics is we crunch numbers. For example, you look at your grades not individually, but as an average, and you total up your grades as well. Those are both statistics. Totals and averages are two of the most common statistics. We also use statistics to determine significance. So in biology, this is the most common use for statistics, is to compare two different populations and see if they are statistically different, if that's a significant difference. I do like to warn that statistics themselves don't lie, but the way that people report statistics can sometimes be misleading. How I explain this is with a story of 4 pies. So this is a fictional story, but I think it helps to show how statistics, even though they don't lie, can be used to tell lies. I have 3 siblings, so there are 4 of us total. And we go home for Thanksgiving, and Mom has made us each our very own blueberry pie. So there are 4 blueberry pies. So these are the 4 pies right here. 1, 2, 3, 4. There's a snowstorm at Thanksgiving, and we don't get there until the following weekend. And when I get home first, and my mom tells me, I made you each your own blueberry pie, but they've been sitting for a week. And one of those pies has bugs in it. And one of those pies has gone moldy. And one of those pies is moldy and it has bugs. So there's only 1 pie left that's good. My mom tells me I need to split that 1 good blueberry pie into 4 and share it with my other siblings. I don't want to do that. So I hide all of the pies, and when my siblings come home, I tell them that half of the pies are moldy and half of the pies have bugs. So my siblings hear that and they're like, 50% of the pies of mold, 50% of the pies of bugs, that's all of the pies. There's no pie left for us. But I'm not lying, because 2 out of 4 of the pies do have bugs in them, right? 1, 2. And 2 out of 4 of the pies do have mold, 1, 2. But that is not considering overlap, that this pie has both of those things. So when I say half the pies have mold and half the pies have bugs, I'm not lying, but I'm purposely misleading my siblings. And this is how statistics are frequently used to misconstrue the facts. We're going to start with some easy stats. So these are ones that you've probably used before. The mean is the average. So when we add up all the numbers and then divide by how many numbers there are, so we're taking our total, oh, that doesn't show up. So we're taking our total and then we're dividing by the number of numbers. That gives us our average. The median is really easy. It is if you line up all the numbers in a row, 1, 2, 3, 4, 5, 6, 7, the middle one is the median. It's that easy. They have to be in order though, highest to lowest. The mode is the most frequently occurring number. So in a very large data set, if you have a number that's occurring a lot, that'll be your mode. For example, I have measured the heights of 8 4-year-old red oak trees. These numbers here are the heights in centimeters of 4-year-old red oak trees, so little saplings. What is the mean? What is the average? So what we do here, I feel like you guys probably already know this, but I'm just going to go through it pretty quick for those who need a reminder. We're going to add all those up and get a total. I don't know if you can see that, but the total equals 680. And then we're going to take that total and we'll divide it by the sample size. So it's 680 divided by 8, because there's 1, 2, 3, 4, 5, 6, 7, 8 numbers. 680 divided by 8 is 85. So that is our mean. And I have these as multiple choice because in a classroom I have a little quiz. The median is a little bit easier because all of our numbers up here, 90, 89, 89, 88, 87, 81, 88, 76, these are already in order. So the middle number, 1, 2, 3, 4, 1, 2, 3, 4, we have 2 middle numbers. If there were only 7 numbers, then 4 would be the median. But because we have 2, we need to add them up and get the middle, the divide by 2, and get the average of these 2 numbers. And then we take 175 divided by 2. The mode is the number that occurs most frequently. In this data set, there's only one number that occurs more than once. So it is our mode. I'm going to come back to mean, median, and mode in a minute. But first I want to talk about graphing. So you've probably done lots of different graphs in your life, and some of them might have been bar charts. But when we make a bar chart where we have the independent variable on the x-axis and the frequency on the y-axis, so how often those numbers occur, that is a histogram. So we're showing we had 1, 2, 3, 4, 5, we had 1, 1, and 2 2s, and 3 3s, and 3 4s, and 2 5s, and 1 6. This is a histogram, specifically looking at the frequency of our independent variable. We get some different histogram patterns. Well, I got 2 at once. So the normal curve is a pretty common one where the middle number is also your mode and your median. So that average is also the middle. So your middle number, your median, is your most frequently occurring number, your mode, and it's also your average, your mean. When that normal curve gets skewed a little bit, pushed over, this one is skewed to this side, but they can go either way. Now your middle number is over here and your mode is over here. So your mode and your average are probably still really similar, but your median is skewed. The last one is bimodal. So here we have our middle number, and our average is probably somewhere in here near our middle number, our median, but we have 2 modes. This is bimodal. And you'll see this sometimes with grades, where you get some high grades and some low grades and no in between. Typically, we get a normal curve with grades because normal curves are really common. That's why they're called normal curves. So as I was saying before, that normal curve, that mode is your middle number, is your mean. So your average, your middle number, and your most frequently occurring number are in the same spot. This makes your data really strong because you can compare your mean and you know that your mean is the middle of your population and also most of your population. The mean represents the majority of the population. So that makes for really strong data. We call it the normal curve because it normally occurs. If you went out and measured 100 white pine needles, You get some really short ones and some really long ones, but most of them would be in the same size. If you go and weighed 100 fish, you'd get some really little ones, some really big ones, but most of them would be in the middle. This curve is really normal. We see it a lot. So is your data normal? Do you have that normal curve? Do you have your mean, median, and mode all in the same spot? If you do, you can run a parametric statistic. It assumes that your mean, median, and mode are all the same, that your mean is representative of your population. Those are called parametric statistics, and the t-test that we're going to learn later is a parametric statistic. If you don't have a normal curve, if you don't have normal data, then you have to run a non-parametric statistic. So it's not assuming that the mean is representative of the population. It uses other things like median. And next semester, we'll learn the chi-square test. It's a non-parametric statistic. And that's it for our starter to stats lesson. We've got a couple more, so stay tuned.